So let us discuss about simple harmonic motion. Just now I have told you, if the acceleration of the body is directly proportional to its displacement in opposite direction and always is directed towards the mean position of its rest, then we can call the motion of the body as a simple harmonic. Let us take the same in the form of a small equation now. Acceleration of the body is directly proportional to its displacement, but opposite in direction means we just used to put a negative sign before that. So I now can rewrite the same thing this way: acceleration is proportional to minus displacement. I just call the displacement as y here. That negative sign indicates that the displacement is opposite in direction to that of acceleration, or vice versa. So if you take the same equation this way, acceleration is equal to a constant omega square into y. What is this omega over here? It is actually angular frequency of the body. This angular frequency has got another name as well, angular velocity. It is the rate of the angle rotated by the body. That in the sense we can understand this way: omega is equal to d theta by dt, rate of change of angle rotated by the body. That is what we call it as angular frequency. This negative sign, once again I repeat, indicates that a and y are opposite to each other in directions. When you take this equation with only magnitude part of it, without considering the direction of it, I now can write the same this way: omega square is equal to a by y. This of course can be rewritten as omega is equal to a by y under root. This is actually the equation for angular frequency of a body in simple harmonic motion. So this is the first equation what we need to remember: a for acceleration here and y for displacement over here. So we can write omega as under root acceleration divided by displacement. That is a common equation for every body whichever is in simple harmonic motion. So what one has to understand out of this one, you try to take up this one carefully. Omega, whatever we have written in this form, is valid for every body irrespective of simple pendulum or a loaded spring oscillating vertically or whatever. Any body we can consider. The thing is that body should be in simple harmonic motion. Then we can directly apply this equation to calculate its angular frequency. Now omega, we in fact know this one as 2 pi into n. What is this n now to be called? N is linear frequency. In fact, you know, this is the relation between angular frequency and linear frequency of a body. So omega can be written as 2 pi n. Then what can we write from this equation as n? N is equal to omega by 2 pi. So what is the other equation we can write from this one? 1 by 2 pi under root acceleration by displacement. In other words, we can even rewrite the same this way: 1 by 2 pi under root acceleration divided by displacement of the body. So this is the equation one should remember as far as linear frequency of a body in SHM is concerned. And once again I repeat, this equation is going to be valid for any body whichever is in SHM. There is no consideration for that. Only consideration is this, that the body should be in simple harmonic motion. Now come to the next one. What would be the time period of that oscillating body? Time period basically can be written as reciprocal of frequency. So time period, when it is reciprocal of frequency, we can directly write the same equation this way: T is equal to 2 pi under root y by a. You can even rewrite the same this way as 2 pi root displacement divided by acceleration. So when you consider a body is in simple harmonic motion, then this is the basic equation for its time period as such. Once again, you should understand that the time period is, the equation is common for every body which is in SHM. So one equation for angular frequency, one equation for linear frequency, and one equation for its time period, which are common for every body which is in simple harmonic motion, we have taken. But one thing you should understand from these equations, when we write, acceleration is equal to a constant of proportionality omega square into y we have written. In fact, where from we get this omega? That also omega square is constant of proportionality we are talking about. When we take omega square as constant of proportionality, why it should be like that? Why can't it be something else other than omega square? For all those questions, the answers of course can be taken up from the basic equations of simple harmonic motion of a body.